know that when I give you word problems, I know you can do them. They aren't more than you can handle, and they're usually incredibly straightforward, okay? There's like almost no thinking involved, okay? So here we go. It is September 9th. And again, these are application problems, so they're word problems. I do want you to write down the word problem in your notes. I'm going to dictate the word problem to you. So all you have to do is just keep writing while I talk. You don't have to do the whole like head bob whiplash thing going on, looking at your notes to the board and looking at the word sort of thing. Okay, so here we go. I think these problems are kind of funny. Example 1. Example 1. I like to eat apples and bananas. Write it down. I like to eat apples and bananas. Bananas cost $3 per pound. Bananas cost $3 per pound. And apples cost $4 per pound. Apples cost $4 per pound. Suppose I bought 12 pounds of fruit and spent $41. How many pounds each of apples and bananas did I buy? How many pounds each of apples and bananas did I buy? All right. So the very first thing you need to do when you're approaching any word problem, any application problem, is look at the question. What is the question being asked in this? What are we trying to figure out? No?
I mean, like,
How many? Right here. There's those. How many pounds of apples and bananas did I buy? That's exactly what you're trying to figure out. Okay? You go to the question to figure out what you're trying to find. The question tells us our variables, the unknowns, what we're trying to figure out. All right, so we need to define some variables. So the very first thing you're going to do is you're going to say, what do I need to find? I need to find how many pounds of apples I bought. What could I use to represent apples? A, great choice. We're going to let A equal the number of pounds of apples. You'll notice I didn't use an X or a Y. X and Y are 100% generic and meaningless, okay? So when we have an application problem, it's much better to use letters that sort of match what you're trying to find, okay? So we're going to let A equal the number of pounds of apples. And then what else do we need to figure out? What else? Banana. Yeah, we're going to let B equal the number of pounds of bananas. Please don't just write bananas and apples. Because we're not just buying 7 apples or 7 bananas. We're buying pounds of them. Wow, it's a busy day.
It looks like
Oh, I meant to put yes. Since they're probably gonna send me. Arrive at 12:30. Okay, perfect. Thank you. All right. Sorry about that. Okay.
ginger snap.
So for each problem, the first thing you need to do is figure out what you're trying to find. Those are your unknowns. That's what a variable is. What are we trying to figure out? Then we can go to the other information in the problem. We need to write some equations, okay? And we have a few equations that we can write that talk about the totals of things that I bought. It says, suppose I bought 12 pounds of fruit and spent a total of $41. There's 2 bits of information there. One part talks about the number of pounds of fruit that I bought, and the other thing talks about the total money that I spent. So we're going to have 2 equations. One equation that talks about the total pounds of food, and another equation that talks about the money that I'm spending. So let's talk about the number of pounds of fruit. I bought 12 pounds of fruit. I bought a total, wrong color, a total of 12 pounds of fruit. What made up that 12 pounds? What did I buy? I bought apples and bananas. What represents apples? I bought A pounds of apples, and what else did I buy? B pounds of bananas. Pounds plus pounds equals total pounds. Does that make sense to you? All right. Now let's talk about money, because when it boils down to money, I spent a total of $41. Something plus something gives me $41. Now let's talk about the bananas. No, let's talk about the apples. Apples cost $4 for every single pound. If I bought 1 pound, how much money did I spend? $4. If I bought 2 pounds, how much money do I spend? $8. If I bought 3 pounds, how much money do I spend? $12. What are we doing to get the 4, 8, and the 12? You're multiplying. $4 times every single pound of apples. $4 for every single pound. That's a product. That's multiplying, ladies and gentlemen. Now, bananas cost $3 per pound. So how do I figure out how much I spent on bananas? 3B. $3 for every single pound of bananas. $3 times every single pound. Ladies and gentlemen, that's your system. That's our system, and now we need to solve it. Okay. You can solve using substitution or elimination. Which method do you want to use? Elimination, probably. All right. So I want to get opposites. So what do I need to do so I can cancel out one of these letters? Multiply by not just -1. -3. Very good. I could multiply by -3, or I could multiply by -4. If I multiply by -3, what letter am I eliminating? The B's would eliminate. Good. So we're going to rewrite this. I'm going to distribute my -3. And what do you get when you distribute the -3? -3A, -3B equals -36. Good. Are we changing the bottom equation? That one's staying the same. So 4a plus 3b equals 41. And now we can combine our equations. Negative 3a and 4a makes 1a. Negative 3b and positive 3b, 0, equals negative 36 under 41. 5, yes. What does that mean, a equals 5? I bought 5 apples. 5 pounds of apples. Very good. There's a distinction there. It's really important. Are we done? Did we figure it out? No, what do we need to do? Replace it back into one of your equations. It doesn't matter which one. Which one do you want to plug it into? Top or bottom? Sure. So I'm going to write down my top equation. A plus B equals 12. And I'm going to take the 5 and plug it in for what? A. Very good. So plugging in for A, we'd have 5 plus B equals 12. And then what? Subtract the 5. Subtract the 5. So B equals 7. Okay. In math, we like to follow the status quo. And so when you have a word problem like this, it starts with words. So that means that our problem should end with words. So I'm going to answer the question. I bought 5 pounds of apples and 7 pounds of bananas. And that is the answer to the system. Okay. I will, however, say that on your homework, if you define your variables, then you can end with just your A equals 5 and B equals 7. Okay. So, but you do need to define what your variables are and be specific. Okay. Don't just put A as apples and B as bananas, because it's actually pounds, not the number of them. Okay. All right, let's try one more of these, and then I'll pass out your worksheet and get you started on the first one. Example 2. Example 2. Here we go. At the fair, the Ferris wheel ride. The Ferris wheel ride takes 4 tickets per ride. Ferris wheel ride takes 4 tickets per ride. And the roller coaster takes 7 tickets per ride. Suppose I was able to take 12 rides total. And used a total of 63 tickets. And used a total of 63 tickets. How many times each? How many times each? Did I ride on the Ferris wheel and roller coaster? Ladies and gentlemen, what do we do first? What do we need to do first? Where should I look? That's the question. Look at the question, because the question is telling us what we need to figure out. We need to know, what are we trying to find? So what exactly are we trying to figure out? Yeah, how many times did I ride on the Ferris wheel and the roller coaster? How many times did I ride on the Ferris wheel and the roller coaster? So what am I going to let my variables be? What? F and R, sure. What does F represent then? What about the Ferris wheel? How many times that I rode on the Ferris wheel? So I'm going to say the number of rides on the Ferris wheel. And we said R. What does R represent then? What about the roller coaster? The number of rides on the roller coaster. Yes, number of rides on the roller coaster. Okay, so this represents the number of rides. Very important. Okay, now that we know that we have the number of rides, I'm going to go and look at other information. Suppose I was able to take 12 rides total. Oh, I must have an equation that talks about the number of rides. 12 rides total. So something plus something equals 12 rides. And I use a total of 63 tickets. So there's another total. So I must be talking about the number of tickets. Something plus something equals 63 tickets. So we have two equations, one that talks about the total number of rides and one that talks about the total number of tickets I'm using. If I was able to take 12 total rides, what rides was I talking about? The roller coaster and the Ferris wheel. The number F represents the rides on the Ferris wheel plus what? R, the rides on the roller coaster. Ferris wheel rides plus roller coaster rides equals 12 total rides. Does that make sense to you? Okay. Now let's talk about the number of tickets. What else do we know about tickets? How many per ride? What do we got? 4 tickets per ride on the Ferris wheel and 7 for the roller coaster. So how do I figure out how many tickets I used on the Ferris wheel? 4 times F. 4 tickets for every single ride on the Ferris wheel. Plus what? 7 tickets for every single ride on the roller coaster. 7R. Is this easy or hard? Pretty easy, right? Okay. That, ladies and gentlemen, is our system. What do you want to multiply by to eliminate? I heard -4. Good. So I'm going to take that top equation and multiply through by -4. Diego, what does that give us? When we multiply through by -4, what do we get?
12 by -4. Oh, -4.
And then what?
-4.
Good. -4F, we got a -4 times R, and then 12 times -4 is -48. Are we changing the bottom equation? No, staying the same. Oh, wrong color. Now I can combine. -4F and +4F is 0. -4R and +7R is +3R. -48 and +63 is positive 15. And then what do we need to do? Yeah, by dividing, divide by 3. So R equals 5 rides on the roller coaster. And then what do we need to do? Plug it back in to one of our equations. And again, it doesn't matter which one you use. I'm going to take that 5 and plug it in for R. All right, so we've got F plus 5 equals 12. What's F? 7. So what does that mean? R equals 5 and F equals 7. 5 rides on the roller coaster and 7 rides on the Ferris wheel. 5 rides on the roller coaster and 7 rides on the Ferris wheel. All right, I'm going to pass out your worksheet and then we'll do one.
I'm aware of that.
All right, so we're going to look at number 1 together real fast, just to get you started. And then I've crossed off number 2 and also number 7. Do you need to do those? No, you do not, because I crossed it off. All right. Ryan, this is CP number 26. Let's read this one together. These are slightly different, but again, really like formulaic. It's sort of, you'll see it pretty quickly here. The school that Lisa goes to is selling tickets to the annual talent show. On the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. Does 4 plus 5 equal 102? No, it does not. 4 plus 5 is 9. All right, so don't do that. The school took in $126 on the second day by selling 7 senior citizen tickets and 5 student tickets. What is the price of each 1 senior citizen ticket and 1 student ticket? What do you need to do first? Define the variables. Go to the question. What are we trying to find in this question? What is the price of 1 senior citizen ticket and 1 student ticket? That's what we're trying to find. So we're going to let what? What do you want to use for your variables? Can you use S for both of them? No, you cannot. I'm going to say let C equal the price of a senior citizen ticket. Olivia, what should we let the second thing be? Okay, so S represents what exactly? The price of a student ticket. Good. Okay, so now that we know our variables, now we're going to look at the information that they gave us. In the first sentence, it says, on the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. That's an equation. It's a total of $102. How do we get $102? How did they collect $102? Is it just a 4? 4 times C. Very good, because they collected 4 senior citizen tickets, and this was the cost of each of those tickets. So when you multiply, you're going to get the total money you collected. And then what else makes up that 102? 5 times the number of student tickets. Very good. 4C plus 5S equals 102. Second sentence, the school took in $126 by selling 7 senior citizen tickets and 5 student tickets. What makes up the $126? Seven senior citizen tickets, so 7 times C, and then 5 student tickets, so 5 times S. 5 tickets at $20 each would get you a certain amount of money. You multiply those. So this is your system, ladies and gentlemen. It's a slightly different looking system, but still easy to figure out. Look, I have matching 5s. What do I need to do to eliminate? Yeah, multiply by -1. So I'm going to multiply that top equation by -1. And then I think you guys can solve from there. So I have -4C, -5S equals -102. Whoops, I ran out of room. Am I changing the bottom equation? That one's staying the same. So 7C plus 5S equals 126. And you guys can add those up and plug them back into either equation. It doesn't matter which equation. You do not need to do 2 and you do not need to do 7. And the answers are in the back. Okay. Keep going. Finish that one up.